Prepare for a cosmic catastrophe on a scale never seen before. Betelgeuse, the terrifying descent of a red giant, signals across space. Astronomers have discovered something profound about this massive object utilizing the James Webb Space Telescope. Brian Cox has issued a very serious warning. The persistent question: is there a possibility that we will soon witness a massive supernova explosion that will forever alter the night sky? In the vastness of the universe, stars are born, live, and die in extraordinary ways. Recently, a single star has captured the attention and concern of astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out in the constellation of Orion. A large and very old star. Its reddish hue with fluctuating brightness has always fascinated me. But more recently, people have become even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a major event in its history. But what could these changes in Betelgeuse mean for us? The beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant that is 900 times greater than our Sun, something difficult for humans to comprehend. Imagine a star so large that if it were to replace our Sun, its surface would reach beyond the orbit of Mars, surrounding Venus, Earth, and Mars. This enormous size not only shows how impressive Betelgeuse physically is, but also at what stage of its life cycle it is right now. As a red supergiant, Betelgeuse is coming to an end. Its expansion and contraction during this phase occur after hydrogen is converted to helium in its core. However, the star is believed to be between 8 and 8.5 million years old. It's been changing significantly over tens of millions of years to become the red giant we see today. It is now in its final stage as a red supergiant. Supergiant stars like Betelgeuse undergo significant changes throughout their lives due to the constant pressures of nuclear fusion and gravity. What distinguishes this stage of Betelgeuse? Its reddish hue is due to the fact that its surface is cooler than other stars, such as the Sun. While the surface of the Sun has a temperature of about 5,500 Kelvin, the surface of Betelgeuse is about 3,500 Kelvin. Because of this lower temperature, light from Betelgeuse has a certain wavelength that gives the impression of red. But this color is not just an appearance. It tells us something about the physical condition of the star and the processes that take place in its huge gaseous volume. The color of Betelgeuse has evolved over time. In the Roman and Chinese eras, Betelgeuse was said to be yellow about 2,000 years ago. In the 9th century, Arab astronomers were the first to claim that this star had a reddish hue. This change in hue throughout human and scientific history has also shown how the star has evolved over time. An additional intriguing thing about Betelgeuse is that its brightness varies over time. It is a variable star, which results in an increase and decrease in its brightness regularly. This variation has fascinated scientists and skywatchers for hundreds of years. Betelgeuse goes through a 400-day brightening cycle and a cycle that lasts 5 years. As early as 1836, Sir John Herschel wrote about these cycles. There are stories that go back even further, but what exactly gives Betelgeuse its mystique is not only how its brightness changes, but also how erratic it can be. In comparison, many stars that dim and brighten in predictable ways, Betelgeuse sometimes breaks from this pattern, which suggests complicated and less understood processes within its enormous structure. Recently, astronomers and stargazers surprised. People all over the world, when they witnessed the appearance of Betelgeuse, changed dramatically and unexpectedly. This is known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the night's brightest stars and an important part of the constellation Orion, began to dim in a mysterious way. The star was fading at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest, normally visible even in locations with a lot of light pollution. It had become much fainter, and onlookers could make out the contrast. Despite this, the paradox of time complicates observing Betelgeuse, as it takes a long time for the star's light to reach us. In Betelgeuse's case, which we observe as it existed nearly 654 years ago because it is about 654 light-years away. This time lag makes it difficult to anticipate and keep an eye on its rapid changes in behavior. The Betelgeuse dimming event was a reminder of how complicated it is to observe the night sky in real time and how little we know about this bizarre universe of space and time. Andrea Dupree, Deputy Director of the Harvard-Smithsonian Center for Astrophysics, and her team took a close look at the dramatic events in Betelgeuse as part of a 3-year study to track changes in the star's outer atmosphere using Hubble. These observations provided new insights into how a variable star like Betelgeuse works. Variable stars regularly expand and contract, causing their brightness to change. The researchers were able to observe the star's surface layers, heated, in part by swirling convection cells thanks to Hubble's sensitivity to ultraviolet light. Studies of Hubble spectra taken at different times in 2019 and 2020 helped find out how quickly things were moving in the upper atmosphere of Betelgeuse. They found that material was moving from the star's surface into its atmosphere at about 200,000 mph, eventually reaching millions of miles away from Betelgeuse. This movement of material contributed to the formation of a dust cloud that made the star appear less bright for 3 months. Dupree and her team thought that about twice as much material from Betelgeuse's southern hemisphere had been thrown away. This mass loss was remarkable because it occurred much more quickly than expected. Astronomers wondered whether this could be an indication of an upcoming supernova explosion, given how large the mass release was and how faint the star became. At 654 light-years from Earth, Betelgeuse's conduct continues to be a mystery. Such an explosion would be visible from space and would provide individuals a rare chance to see a supernova up close. But the question remains, is this a sign that a supernova is about to occur, or is it simply a one-time event in the long and complicated life of Betelgeuse? Several theories have been proposed to explain this rapid change. Please tell us what you think in the box below. If you like the video, be sure to like and subscribe, and also turn on the notification bell to receive any content like this. Thanks for watching the video, and I'll see you in the next one. Despite the many studies conducted on Betelgeuse, there remains a cloud of uncertainty around what exactly is happening inside this massive star. The physical processes that control its behavior are far more complex than initially thought. As researchers continue to monitor the star, they've observed not only changes in brightness, but also subtle shifts in the star's outer layers that may point to deeper convective activity. These movements within the star, which resemble massive, boiling cells of hot gas, could be a factor in the irregular patterns observed from Earth. Scientists now believe that these convection currents, which stir the star's outer shell, may periodically carry cooler material, forming temporary dark spots that dim the star's overall appearance. What makes Betelgeuse even more fascinating is the potential for it to explode in a spectacular supernova at any moment, cosmically speaking. Such an event would be one of the most significant astronomical observations in modern history. It would be bright enough to cast shadows at night and remain visible during the day for several weeks, perhaps even months. Some scientists estimate it could outshine the full moon. However, even with this dramatic potential, it's not guaranteed that the star will explode soon. Predictions vary widely, with some astronomers suggesting the supernova may still be tens of thousands of years away. Still, the level of activity observed in recent years persists in implying that Betelgeuse is nearing the end of its life. The star is currently burning heavier elements in its core, a process that proceeds rapidly when both hydrogen and helium are used up. When iron begins to accumulate at the center, fusion is no longer possible, leading to a catastrophic core collapse in a matter of seconds. This collapse would trigger a shock wave that rips through the star's outer layers, resulting in a titanic explosion that sends heavy elements including uranium, gold, and silver through space and time. These elements contribute to the creation of planets and, eventually, life. Interestingly, the shock of such an explosion would not pose a danger to Earth. Despite Betelgeuse's massive size and energy, at 654 light-years away, it is far enough that we would not be harmed even by a supernova. However, Earth's atmosphere could experience minor effects, such as increased radiation levels in the upper atmosphere or brief disturbances in satellite communications and space weather. But more than anything, it would be a rare chance for humanity to witness a cosmic phenomenon that has shaped galaxies since the beginning of time. This is why so many eyes remain fixed on this ancient star. Its behavior has not only captivated scientists, but also sparked renewed public interest in astronomy. Amateurs with instruments, sky maps, and telescopes have been watching Betelgeuse night after night, hoping to catch any sign of a significant change.